Welcome back. This is day 3 of our right triangles unit. Today we'll be simplifying and multiplying square roots. Enjoy! Oh yeah, it's that time again. We have some math problems here and we need you to do them now.
Let's go over this
Pause the video, complete the problems,
and
return to the video when you're
each of
done.
the following square roots on the number line. So let's take the square root of 50. Where does square root of 50 go? Well, square root of 50, I know this, it's going to go, square root of 49 is 7, and I also know the square root of 64 is 8. So that means square root of 50 is going to have to be somewhere right around here, pretty close to square root of 49. So I'm going to put it right there, square root of 50. All right, so that's what you're doing for these problems. Square root of 12, let's think about 12. Where is 12 going to be? 3 times 3 is 9, 4 times 4 is 16. Oh, there we go. So square root of 9 is 3, square root of 16 is 4. So 12 will be in between here somewhere. Let's see. Maybe more closer to the middle. It looks like it's somewhere in the middle. And again, we're just estimating right now. If you had a calculator, go ahead and use your calculator and get the answer, but this is how we can do it without even using a calculator. Square root of 20 is between 16 and 25. Perfect. So if I put square root of 20 on this number line, I think I'm going to put 18 right around here, and then the next one is 20. So I'm going to say somewhere like right here. So the first one is going to be the square root of 18, and this next one is going to be the square root of 20. Okay, so there we go. So if I'm looking at those answers, that's how I find them. Just basically finding the square roots to the left and right to see where it fits between. All right, so for this problem, simplify each square root. So we're gonna have to do some math here. We're gonna start simplifying. That might be something you hate, but in order to do that, I want you to use GeoGebra to do it with a calculator first. So let's see how to do this on the calculator, and then we'll learn how to do it by hand. So go ahead and go to GeoGebra, and we'll show you how to type this in. All you have to do is hit simplify, and then inside the parentheses, type in whatever square root you're looking for. All right, so go ahead, give that a shot, and then we'll come back and see how to do this by hand. All right, so let's go to GeoGebra. Just go to geogebra.org, hit start calculator, and we're gonna simplify our radicals. So the first one, and what you're gonna do is you're just gonna type in the word, and what you notice is type in the word simplify, but you'll open up this little code. So you go simplify, and then this gives you the format. So hit inside the parenthesis, and then you're gonna enter in here the square root of 50. So I'm gonna go to the keyboard to find it. So I'll go square root of 50, and then I'll press enter. So there we go, I got that one, and my answer is the square root of 5 square root of 2. Let me just change this real quick because I have my settings on, I believe I have no decimal places. Yep, 0 decimal places. Let's go to 10. All right, there we go. Just because that looked weird to me for a second. All right, so let's try the next one. So on the next one, we wanted the square root of 12. So we can just type in simplify, and we want the square root of 12. So if you want to go faster, you can just type in SQRT, and that will give you the square root. So you see that? It makes the square root, and I want the square root of 12. And I'm done with that one. 2 radical 3. Very nice. So let's try a couple more. Simplify. I'm going to try square root, and then I'll put a parenthesis, and it changes to a square root symbol. So square root of 20, and 2 radical 5 is my answer. So very nice. I like this little program here. Simplify the square root of 18, and we're done. So there we go. So the answers for this, the square root of 50 was 5 radical 2, square root of 12 is 2 radical 3, square root of 20 is 2 radical 5, and square root of 18 is 3 radical 2. All right, let's go to see how do we do this by hand now. All right, so now that you got your answers for each one of these, we should have got the answer for the first one should have been 5 square root of 2. we should have got the answer for the second one, which should have been 2 square root of 3. And then we should have got the third one, which would have been 2 square root of 5. And the last one should have been 3 square root of 2. All right, so now let's take a look at each one of these and see if we can figure out. If you study it for a little bit, you probably recognize some, you probably see a pattern going on here. You're like, okay, I kind of see some things. Maybe you do, maybe you don't. But let's take a closer look at these. So here's what's really happening. So take a look at this problem. Well, we know that we can break apart this square root of 50 into two numbers, square root of 25 times square root of 2. And I kind of got a little hint here because there's already a square root of 2 here. So I'm like, okay, well, square root of 2, that means I'm going to need to still have that in my problem. And then I have the square root of 25. But now, what is so special about the square root of 25? Well, we know that 25 can be written as a perfect square, meaning 5 squared. And since it can be written as a perfect square, that means I can simplify that a little more, and the square root and the square are going to simplify out, and we're left with just 5 because they're inverses of each other. So remember that. We've been talking about that for a while now. So that's how we got this answer. So if we look at the second one, use your hint that it already has a square root of 3 in there. So 3 times something is 12. Well, 3 times 4. All right, but now, why is that so important? Again, remember that the square root of 4 can be written as a perfect square. You can write it as 2 squared. All right, and what happens now? Since that is 2 squared, we know we can simplify a square root with a square because those are inverses of each other. And my answer is just 2. The 2 just comes down, and the square root of 3 just comes down right behind it, and that's how we simplify these. So as you're doing these problems, if you know your perfect squares, you can do these really fast. And there's other ways of doing it too, by making tree diagrams and writing everything out. But eventually you'll get kind of quick at this. You'll be like, oh, this is square root of 4 times square root of 5. And why did we pick square root of 4? Well, we know the square root of 4 is a perfect square, so that can be written as 2 squared. And the square root of 5 just comes back down. So the square root of 5 comes down here, and we know we can simplify square root with this little square. And again, not too bad. So hopefully you see how this is working, how these are simplifying. And eventually, when we look at the last one, well, if I was doing this one, I know that's the square root of 9 times the square root of 2, and 9 I know is a perfect square, so that means I can write that as 3 squared. And since we have a square and a square root, they will just cancel each other out because they're inverses of each other, and we're left with 3 radical 2. So there's my answers for each one of these. That's how we're simplifying these. And if we ever ask you to simplify, usually we simplify almost every single time. So every time you try a problem, try to simplify it if possible. And remember, if you're not that great at multiplication, you always have your GeoGebra calculator that can help you out. Let's look at what this, I want you to write this into your notebook, so make sure you have this one. This is the property we're using. This is saying what we can do. So when we see our when we see our numbers, we can break them apart into factors and write them as 2 separate radicals. All right, so that's the rule that we just used. So for instance, you're allowed to, if you like to, like we just did in the last problem, you're allowed to take the square root of 18, and we know that the square root of 18 is 9 times 2, and then we're allowed to break that into 2 radicals. We did it, we skipped a step in our last problem, but we're allowed to do this. So that's what we're doing. All right, we're writing our factors and we're breaking apart into 2 radicals so we can simplify each one separately. All right, and also it works backwards. If you want to put it back together, you just multiply them back together and you are good to go. Let's try the last one. So here we go. Let's see if we understand what's going on here. Which one of the following could be used to simplify the following square root? Explain your reasoning. Well, when we look at these, all of these numbers multiply as 12. 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. But which one of these would help us simplify it? Well, square root of 2 is, well, 2 you cannot write as a perfect square. 12 I cannot write as a perfect, so none of these would help us simplify. That's going to just give us decimal values, and we're not going to be very good there. The square root of 3 is also not a perfect square. 8's not a perfect square either, but 4 is a perfect square. So when we get over here, this right here is the key. Why is this the key? Well, because you know you can write 4 as 2 squared. And as soon as you know that, you're like, okay, that means I can cancel out my square root with my 2, and we are going to be left with 2, and then bring down the square root because that's not a perfect square, and there's my answer. So when you're doing these, you might be factoring your numbers into numbers, but they don't help you out. Like if you would have took this square root of 24 and made 2 and 24, that's not going to help you out at all. Either will the 3 and the 8. That's not going to help you out either. We're looking for perfect squares. We need to be able to find numbers that make perfect squares. So remember some of the perfect squares that we've been studying. Let's list them out. 1, 4, 9. What else? Usually by that time we're usually done if we're doing problems, but 16. 25. These are all my perfect squares. So I want one of my numbers to be one of those when I'm factoring. All right, 36, 49. What else? 49, 7 times 7, 8 times 8, 64. 9 times 9, 81, and 100. So usually we're looking for these numbers. That's what we're looking for when we're making pairs. All right, hope that helps. Higher and higher in math, we're going to just start doing more and more things by hand and more work with just more properties. So we need to be able to multiply radicals together. So I wanted you to have this property here, and let's take a closer look at what's going on here. So in this problem, well, we notice a radical b times c radical d. These are very simple. All we're doing is multiplying whatever's in front of the radical, so that's this little piece. Just multiply a and c together, and then you'll get the square root of whatever's underneath the radical, so b times d. So this is how we're going to do these problems. So it's not too tough. Just multiply what's in front, the coefficient, and then we're going to multiply underneath the radical. So let's take a look at each one of these. So in this problem, we are going to get, well, the first one, 3 times 5, real quick, it's going to be 15. And then we'll have the square root of 2 times 2, which is 4. So that's it. That's all we're doing. Just multiply whatever's in front of the radical. So the 3 and the 5 go together. And then whatever's underneath the radical get multiplied together. So the 2 and the 2. And if you can simplify, then you should simplify. So this is going to be 15 square root of 4. But you know 4 is 2 squared. So that means the radical and the square are going to simplify out. So that's going to be really nice and simple. 5 times or 15 times 2. So whatever that is, that's 30. All right. So again, you'll get faster at this. You'll start skipping steps as we go. But it shouldn't be too challenging. So in the next problem, let's multiply what's in front of my radical. So I got 2, and over here, there's nothing here. So I'm going to put a 1 there. So remember, just add a 1 right there just so you have something to multiply with. So I'll get 2 times the square root of whatever is underneath the radical now. So 3 and 12, which is 36. And this shouldn't be too bad. This will be 2. We know what the square root of 36 is 6, but let me write it out the long way. So this is also 6 squared. And those cancel out nice and simple. Cancel those, and we're left with 2 times 6, which is 12. That's it. So again, you'll start getting faster and faster at this as you start working. So like 3 times 2 will be 6, 8 times 2 is 16, and I know the square root of 16 is 4, so then I'm going to get 24. Okay, you'll get quicker and quicker. I think this one, we already had this one. This is 18. And let's simplify that really quick. So I know this is the square root of 9 times the square root of 2. Answer is 3 square root of 2. All right, so you'll be having problems that look like this. up this lesson. This is a easy problem, fun problem. It says simplify. So we have the square root of 5 squared. Well, if you think about it, square rooting and squaring are just inverses of each other. So this square root will cancel out with this square. So my answer for this problem is just 5. You don't have to do anything as long as you know that. As long as you know that a square root and inverse and a square are inverses of each other, that will just happen. So look at this problem. We're going to square 3, and then we're going to take the square root of it. Those are inverses of each other. So my answer for this one is just going to be 3. All right. Hopefully that makes sense. Hopefully you're starting to connect all your ideas here. And good luck.